Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at the types of network address translation. We'll be discussing static NAT, dynamic NAT, port address translation, next available port, Nat and Pat comparison, and then finally, packets without a layer 4 segment. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. When we talk about network address translation, there are several types on how we can map those inside and outside addresses together. The first type is a static map. This is a one-to-one mapping, and so that's important to remember. One-to-one, where we have one internal address that gets mapped to one external address. The scenario here, we are using PC4 is out here on the internet, and we want to connect into server 1 here, and we're going to use SSH to do that. Whatever the reason is, you have to do that, so you have to set up this network address translation. Network address translation happens on our edge router. Right here is our edge router between the inside and outside of our network. So this is where our NAT is, network address translation. And what we do on the server is say SSH from a command prompt. That's how you open up a SSH client. And then you put in the IP address of 209.165.200.126. You hit go, and then from PC4, it gets routed across the internet, and it comes to this interface. This interface is actually where that IP address exists, where 209.165.200.226. That is actually where this address is. But because you went in and you actually set up NAT saying any traffic that comes in looking for this address, we're going to translate it and change it to this IP address, the 192.168.10.10. So it's translating that 209 address into 168. When it does that translation, then we can send it out to the local area network, and it can get delivered to the final destination. And so anytime anybody connects into this 209.165.200.1.226 address, it's going to get sent to R2. R2 is then going to translate that into 192.168.10.10 and then route it to the destination. If you want to set up a web server or another service inside of your company, let's say on PC3 here, we're going to set up a web server here that's going to host this, and we want to do a static NAT to it, a one-to-one mapping. What we have to do is out here, we have to get another IP address. So instead of having 209.165.200.226, we need to get a second one. So 209.165.200.227. So it's another IP address. Called up your ISP and said, I need another IP address. They're going to go ahead and give it to you. Once again, you set it up on this interface. So that way traffic can get routed across the internet to this device. This device then has a mapping that says, okay, 209.165.200.227 gets mapped to this IP address of 192.168.10.12. And so it does this translation. When it does that translation, it can then go and deliver it to the web server. R2 is doing all of this translation for us. And when we look here, we can see that that's what we are looking at down here. That it's a one-to-one. You need one local inside address to one inside global address that's set up on R2. This is a one-to-one mapping. So for every inside device you have that you want to use static NAT, a one-to-one mapping, you need to have that external IP address, a global IP address configured so that way R2 can do the translation for you. If you like this episode on the types of network address translation and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Another type of NAT is called dynamic NAT. Once again, this is a one-to-one mapping, so 1-to-1, but it's on a first come, first serve basis. First come, first served. Now, what do I mean by that? Typically, when you set up dynamic NAT, you get a pool of IP addresses from your internet service provider. You call up your internet service provider and say, hey, I need 5 IP addresses. Internet provider says, yep, we'll give you 5 IP addresses. We're going to charge you this much per month for these 5 IP addresses. Then you can take and you can set up those 5 IP addresses right here on your edge device. We can set up our 5 IPs right here. Once again, these are 5 publicly routable IP addresses. You set that up here. Then with dynamic NAT, what happens is when a PC wants to make a connection to the outside, and a lot of times we're talking outside or inside communications to the outside. PC3 wants to make a connection to someplace on the internet. There's a web server out there where they need to go to get the information. So they send out this HTTP request to the IP address of our web server. It comes up here, comes to the router. The router examines it. It finds that there's a private IP address in there. If there's a private IP address, the router knows when it hits the internet, it's going to get discarded. So what we have to do is translate that source private IP address, the 192.168.10.12, into a public IP address. And what we're going to do is we're going to assign it one of our 5 IP addresses we got from our ISP. We're going to go through and set that up. Right here, we can see that 192.168.10.12, we now have mapped it to 209.165.200.226. We have set that mapping up here. And so anytime it wants to communicate, it does that. Now, when PC2 wants to do that, PC2 here is going to make a request, and then we're going to set up a static mapping from 10.12 to 200.227. And we set up a static mapping to that. That way, when the request goes out across the internet, that response can come back to that IP address we have set up on the outside of our router. It can get routed there, and then we translate it back into an IP address there. Now, the trick here is you need to have enough public IP addresses. So you need to have enough of these IP addresses you got from your internet service provider to satisfy the total number of simultaneous user connections. So the amount of users that want to use the internet at one time, you need to have enough publicly accessible IP addresses. Because this is dynamic, if PC12 right here, if PC12 doesn't use that connection for a certain amount of time, it's going to disassociate it in the network address translation table and make this available. And so after a while, if that connection, that translation isn't used, it'll become available for somebody else to do it. Right now, if we have 5 IP addresses in our pool, we have 5 devices that want to connect in, or that are connected, that are using this network address translation. What happens to that 6th person? Well, that 6th person isn't going to get a connection. It's going to say website unreachable, destination unreachable. And that's what they're going to get, because this is a one-to-one mapping. First come, first serve. You have to have enough public IP addresses for the number of simultaneous users you want. And the final type of address translation we're going to talk about is port address translation, or commonly called PAT. Now, PAT's a little bit different than the other 2 we talked about. PAT is a one-to-many translation. Now, what do I mean by one-to-many? You can have one external IP address to map to many internal IP addresses. This is probably what you're using at home. At home, from your internet connection provider, you're going to go into some sort of router. And that router is going to get one IP address from your internet service provider. But on your internal network, I'm willing to bet you have more than one device. You probably have a whole bunch of devices, several computers, streaming devices. If you're into home automation, you're going to have some Alexa products or Google Home products on there. You're going to have a whole bunch of devices on there. But all those can work at one time and share that one external IP address. That's a great example of port address translation. Here we have an example. We have the inside of our network. On the inside, we have a couple PCs. On the outside, we have some servers that we want to connect to through the internet. What we have here is we have our R2. This R2, router 2 right here, is going to do our network address translation. When we connected up R2 to the internet, it pulled an IP address right here. The IP address it pulled right here is 209.165.200.226. Now that could be an IP address you pull from DHCP from your internet service provider. You could have manually set up, and your ISP said you set that IP address there up on your external interface. But this is the IP address of this interface right here. And what happens here is the inside PC, it makes a request. It comes out to R1 here, its default gateway, and it sees, okay, PC1 is going to make a request. It's going to make a request of server 1 here. Server 1 is over here. So I'm going to translate this address from 192.168.10.10 into a publicly accessible address. Now, when it gets the IP address from PC1, this could be like a web page. And so it's a randomly chosen port number here, or like your tabs in your browser. Each of your tabs in your browsers has a layer 4 port number that was randomly chosen, so that way it knows what information to deliver to what tab. And so this is the inside local IP address of it. It's the IP address of it, and because we're doing port address translation, we have to have port numbers. And so we chose, and it randomly chose 1555 as the port number. And so that is the inside local address of that. Then what we do is we make the request here to our web server. The web server goes out to here, but that request is web traffic, and that's on port 80. So that's the standard port for web traffic, and so we send it to port 80. Now, when it goes through and it does this translation to get rid of the internal private address and put an external address, R2 translates the 192.168.10.10:1555 source address into something that's routable to route that information back, that reply back from the server. And what it does is it goes and puts that public IP address on there, 209.165.200.226, and then it appends that port number that it got from PC1. And so that is 1555. It appends that on there as the source IP address with a port number. It sends out the request, the destination IP address of server 1 here, sends it out there. Server 1 gets that request in and sends back a reply. So then it inverts the source and destination. It routes it back to this IP address here, the 209.165.200.226:1555. R2 gets that in there, and it sees that we made a request to this web server at this address on this port. It checks its network address translation table, and it finds out it came from PC1 on this port. And so it translates it back into that destination IP address into the 192.168.10.10 with a port number of 155.150, with the port number of 1555. And so it does the translation here between those using the port number. Okay, so that's one PC asking to connect into a server on the outside. What happens when a second PC does that? Well, PC 2 wants to connect to a server. It could be the same server, it could be a different server. When it sends that request out, that HTTP request out, it sends it out, but it also generates a port number. Here it's going to generate the port number of 1331. That goes up to our edge router here. That edge router translates that into an IP address. It uses that IP address that was set up here, 209.165.200.226, but then it appends that port number on there, 1331. And so now this becomes the new source IP address of the frame, goes across the internet to server 2, which is our web server. So it goes to port 80 here, gets in the HTTP request, processes it, it sends back an HTTP reply to this IP address, because that's what R2 translated it to. R2 gets that in there, and it knows, it checks its address translation table, and it says, okay, this address, the destination of this address to this port number actually translates to this PC. So let's go ahead and change that destination IP address and port number to our local one here inside of our network, and now we can deliver it. Both of those PCs, PC1 and PC2, when they connected the server, they use technically the same IP address, 209.165.200.226. Same one down here for both requests, but the port numbers were different. These two port numbers were different, and that's how the server keeps track of what request, when it comes in, goes to what PC. Now, this port address translation is also known as NAT with overload. You can call it either way, but technically this is NAT with overload. You're overloading one IP address with a lot of IP addresses, and how we do that is using port address translation. We set up different port numbers, layer 4 port numbers, and append them on our source and destination IP addresses to then be able to translate and sort out who gets which request when it comes back. When we look at our inside, outside, local, and global IP addresses, we can see down here on this table, we can see how they're working right now. So the inside local IP addresses for both of our PCs is the IP address and then that randomly generated port address. We can see this is PC1 right here. This is PC2. So when once again, this is location, and then this is point of view. When we're on the inside of our network and we want to reach these PCs in here, how do we get there? We go to the IP address, and then we also append the port number. Then we have the inside global addresses. Once again, the location is inside, our point of view is from the global point of view. So we're talking about the inside devices, but from the outside on the internet, what address do we have to go to? We have to go to the 209.165.200.26 addresses, because that's routable across the internet. And then we also append the port number so we can keep track of, in our port address translation, which device it's going to. Our outside local IP address, so we have location and point of view. The location of the devices are outside of our network, so we're talking about the web servers here. And the point of view is from our local area network. So what addresses do we use to reach those web servers? We use their external IP address, 209.165.200.1, 202.129. And then because we're requesting web traffic, we append the port number, layer 4 port number of port 80 on there because it's an HTTP request. And then finally, our last one here, our location is outside, so we're talking about our web servers outside, and our point of view is where are we viewing it from? On the outside on the internet. So somebody on the internet, how do they want to reach these servers? They're going to use the same address here as our outside local IP addresses. And once again, the outside local and outside global, these two typically are the same. They're typically equal to each other because the address you would use on the inside of your network is the same address somebody would use outside of your network on the internet to reach those web servers on the outside of your network. As we look at Pat, we have these port numbers that are being generated. Pat tries to preserve that original source number. So if that original source number is available, it's going to go ahead and use it. If it's not, it's typically going to increase it by 1. And in this example, we are using 1444, and the next one we want to start will be incremented by 1, or 1445. And it increases and increases. It'll go all the way through the port numbers, basically up until 65,535. Once it runs out of there, if there's another, if there's happens to be another external IP address, it'll try that one. But eventually, it could run out of port numbers and IP addresses. At that point in time, that translation will stop working until some of these older ones that have been doing translation, they release their ports and IP addresses, become available to use again. Looking at Nat and Pat, there's some differences between the two. First one we're going to talk about here is Nat, Network Address Translation. It only modifies the IPv4 address. We can see that the inside global address, so this is the location, this is the point of view. So the device is located inside of my network, but we're viewing it from the outside, from the global point of view. This is the address there. Here's the inside local. So this is location and point of view. So we're on the inside of our network and we're viewing it from our local area network. This is the address. And so this is the translation here. But if we're using Pat modifies both the address and the port number. And so it modifies that. And so when we look at our inside global address, this is the address that we use from the internet to get to our internal device. We have an IP address and a port number right there. And the inside local address is our inside local address with a port number here. This port number could match like it does in this example, or it could be different. And that's where we try to preserve those matching port numbers. Now, some other differences between Nat and Pat. Nat is a one-to-one mapping between the inside local and inside global. Pat is one inside global. So that's the IP address on the outside of your router to many inside local addresses. So it's a one-to-many. Nat is a one-to-one. Pat is a one-to-many. Nat only uses IPv4 addresses. So only IPv4. Pat uses IPv4 and port numbers. So Nat is only the IP address. Pat is the IP address and port number. And finally, for Nat, the inside address required for each inside host accessing the network must be unique. And so because of that one-to-one mapping, for every inside global address, you need to have an outside address. And so An outside address needs to map to that inside address. It's that one-to-one. Where on PAT, you can have that one address and it'll be shared by many devices on the inside of your network. Sometimes you're going to get packets that actually don't have that layer 4 segment. When we look at like ICMP version 4 messages, it will have just layer 3 information. It won't have those layer 4 port numbers in there. Now, each of these protocol types, they handle PAT a little bit differently. For example, for ICMP version 4, query messages, echo requests, and echo replies, those all include what we call a query ID. So this query ID is a number to identify, hey, this is the request that's being sent out. I'm going to look for the reply that has the query ID that matches it. And so that's their own form of port number at that point. ICMP uses that query identifier to identify echo requests and match it with the echo reply. It was my pleasure to provide you with this wonderful episode on types of network address translation. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my social and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I put there just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.